All right. Hello, everyone. Welcome to lecture 5. Oh, sorry, lecture 6. And this is assignment 4, which I have posted today. And I just released it, and it will be due next week, Sunday on midnight. So this is the searchable address book. So this will use your knowledge of dictionaries to make contact lists. So what that will basically be is you'll have a searchable address book. So this searchable address book will be one big dictionary, right? So what your program will do is it will use this information to determine if this contact exists in this dictionary, right? And if this dictionary does exist, sorry, if this person does exist in the address book, we want all the information to be outputted for them. Okay. So what basically you have to do is you have to create a dictionary which can have a contact, which can have all of these possible um, values, right? So it can have a home phone number, it can have mobile phone number. So that contact can have all these different attributes that have to be stored in the dictionary of that contact. So it will be a dictionary within a dictionary. So when you start doing this program, I'm sure you will have more doubts and more concerns, and that is fine. In next class, I expect a lot of people to have questions in this. So I want everyone to get started on assignment 4 as soon as possible, because I do expect this to be a tough one, because this involves nested dictionaries, which we learned about last class, right? So that is just a quick overview. I want everyone to go through this, and then we can have doubts after the next lecture. Does anybody have any questions so far? Just about what we're trying to do here, not about what the code will be. I want you to try it out first yourself, but about what this address book is. No? Okay. So let's go to our presentation for today. And if you guys thought that we were done with data structures, we are not done with data structures yet. We have 2 more to go, but today we should be able to finish them up. Okay, so today we're going to do data structures part 3. So what are data structures? A quick recap. Data structures are essentially a means for storing and organizing a collection of data values. What are some data types? Sorry, what are some data structures that we've already learned about? Who remembers from the last 2 weeks? You can unmute yourself and speak. Nobody?
Booleans.
So Booleans are a primitive data type, right? Data structures are something that there's a collection of those data types. So what are some collections that we've learned about? Sets, right? So set
array.
array is a data structure, correct? And we've learned one more. Who can tell me? I was just talking about
Sets.
dictionaries, right?
Yeah,
They're written
Yes,
right over here. So
dictionary.
we have sets, tuples, arrays, dictionaries, objects. So today we're going to learn about lists first. So what is a list? A list is an ordered collection of non-unique values that are of any type and are mutable. Okay, So this makes it different from the other three collections that we've done so far. Okay, so how can somebody describe a list for me like this? Sorry, an array for me like this. What kind of a collection is an array? Anyone?
An
What is
array.
the
Sorry,
what is the difference between an array and a list just by looking at this? Can anybody guess?
an array. An array collects data of the same type, whereas this can collect data both can combine data types like integer, string, and
Correct.
floats.
Right, correct. That's a good catch. So over here it says they can be of any type. So when we have data types that can be of any type and we want to store them in an ordered collection of non-unique values that are mutable, it's a list. But when they're of the same type, it's an array. So that is the difference between an array and a list. Other than that, you will find that most of the things that you can do with an array, you can also do with a list. So let's look at some of the basics here. So what is a list? It is ordered. So the elements within a list have a defined order. So the order in which you enter them is the order in which they will remain. So as we saw in sets, this does not happen. Sometimes when we add elements, they get placed in random orders. They can be placed in second place, third, wherever, right? So now we look at non-unique. So unlike a set, you can have multiple of the same values in a list. So in a set, if you put like repeated values inside a set, the output won't have those repeated values. It will simply make them one value. Whereas in a list, they will become separate values within that list. Does everyone understand what non-unique means? Okay.
Sorry, come again. Sorry.
So non-unique, so in a set, if you remember, you cannot have two of the same elements in it, right? That means that you can only have unique values in it. That is not the case in a list. In a list, you can have non-unique values. That means you can have the same values over and over. So as you can see in this example below that, we have two times, we have three times, four times, then we have hello two times, and it's not causing any issues. Whereas in a set, if you put these values in, it will cause them to not be repeated. So we look at an example when we switch to PyCharm. Okay. So any type, unlike an array, when creating a list, you do not need to specify the type of the element within the list, and the elements of the list can be of any type needed. So as you can see in the example above it, we have numbers, we have strings, and we have booleans in the same data structure, right? So they can be of any type. So they are mutable. You can alter the values of the elements in a list. Okay. So my list equals 1, 2, 3, 4 up to 0. Then my list 9 is equal to 10. Then when we print my list again, as you can see, the ninth value has been changed to 10. If you remember, we start counting from 0, not 1, when we're checking the index. Okay, I see something in chat. Let me check real quick. So non-unique means a number can be repeated several times, correct? So not just a number, but any kind of data type. So as you can see, even a string can be repeated multiple times, a Boolean value can be repeated multiple times, and so on. So accessing individual elements. So before we get into indexing and everything, let's look at a few examples of lists in PyCharm. Okay. Is this readable to everyone? Is the size okay?
It's too
No,
tiny.
no,
It's too
assume
tiny.
it's
Okay, let me switch screens over here. Give me a second. Okay, is this better?
Yes.
Okay, perfect.
It's better, but if you can even do some more, sorry.
Okay, let's see if we can do something. View. Hmm. I don't see an option to zoom in. For next time, I will try to uh, have that done beforehand. Okay, for this lecture, let's continue at this size. So x equal, okay, so this was something I was doing, sorry. Okay, so we are going to first see what unique means. Let's clear that out. Okay, so let's make a set first. So let's call it set one. 1, 2, 2, 3, 4, 4. Oh, this is a Boolean. We don't need that. This is capital. Okay. Now let's copy this and make a list out of these same elements. Okay. Let's call it list one. And we'll simply just change these brackets and it will become a list, right? So now we print set one first, and then we print list one. So what will the difference be? So what will set one be? First, tell me what will set one be. Let's just print set one first. Put that in chat. Just put the numbers in it. You don't need to be, you can ignore the Boolean values, just the numbers. What will be the numbers inside set one? So we have 1, 2, 3, 4. 1, 2, 3, 4, true, false. Okay, right? Everyone seems to agree with that. So let's print it out. So we have false 1, 2, 3, 4. As we said, it is also not ordered, so it just decided not to care about what the order is, right? So now we print out list one. Now what will the answer be? What will the numbers be? So we have 1, 2, 2, 3, 4, 4. Does everyone agree with that? Seem to agree with that? Why does it eliminate the bool? That is an interesting question. It did ignore the true value over here. Oh, okay, so there's probably our answer. So maybe if we do something like 8 less than 7, or sorry, greater than 7. Oh, set one. Okay, I actually don't know why it eliminated true from there. I'll get you an answer for this. That's a good question. So if you print out list one over here, you'll see everything gets printed out. It just it will keep the order. It will not eliminate any repeated values as well. Is that clear? I will get us an answer for why it eliminates this true from here. I do not know. I will get us the answer. Okay. Great. So let's look at lists a little bit more. Let's go back to our presentation. There we go. Okay, so now we're looking at individual elements, right? So we have to access individual elements. Oh, okay, right. Sorry. So this is quite similar to arrays. If you remember from arrays, we simply use square brackets after the name of the list or the array. And then we start the index from 0. And then we just simply write the number of the element we want, right? So for example, 1 is at the 0 place. 2, let me mark this actually. Sorry. Okay. So this 1 over here is at the 0 place. Then we have 1, 2, 3, 4, 5, 6, 7, 8, 9, right? This is how the indexes go in computer science. Okay. We start with 0 and then we continue. I think we have something in chat. I think the array is peculiar to C language and not Python. So the array can be used in Python by including it, as I mentioned earlier, by using a library. But you are right, C language is what heavily uses arrays. Pythons mostly make use of lists because they are so similar in Python, right? Oh, why does this keep doing this? Okay. So this is quite similar to arrays. Does everyone want me to give a few examples of how indexing goes? Ignore this point for now. I'm coming to this. Everything above this should be above board in terms of arrays. Is everyone clear on this? So we start the indexing with 0, we go to 1, and then we continue. If anybody needs an example, I'll give you one. Okay.
Let's give one.
Okay. So let's go to PyCharm. Okay, so we already have our list made over here. Let's use it. All right, so let's say we want to access this true value over here, right? So let's start counting the indexes. So we start with 0, 1, 2, 3, 4, 5, 6, 7, 8, right? So this is index number 6. So how are we going to access it? We're simply going to write list 1 and then 6 with square brackets. Okay, this accesses it, and now to print it out, we can write print. So now when we run this code, we have true over here, which is what we were trying to print, right? So is indexing clear? We start with 0 and then we go on. We pick the number we're trying to print out, or just trying to put in a variable, or whatever you're trying to do with it, right? Okay, so let's move back to our presentation. So over here we have negative indexes. So lists can also be negative indexed. So what is negative indexing? Well, what happens is when we do -1, it starts from the back. Okay, so let me show you quickly how that looks. So it starts from the back. So we have -1, -2, -3, -4, -5, and so on. Okay, so this is how we negative index. So this is why when we do my list -1, we have 10 over here, right? So let's look at an example for this in PyCharm. So this is the list we were using, right? So let's try to negative index. So we were trying to print out true. Let's try to use negative indexes to try to print it out. So we start from the back with -1. So -1, -2, -3. So the index for true is -3. So we use the same method, write the name of the list, oh, name of the list, right? Then we put square brackets and then the negative index. And if we want to print this out, we're going to put print and then put this in brackets. So if we print this out, we have true. Right? This is the value we were trying to print. So does everyone understand how negative indexes work? Okay. So let's move back to the presentation. Okay. So we have over here list slicing. So this is something that is very crucial and also interesting, right? So what we can do is we can take a part of the list, we can slice it up, and we can just make a different list out of it, right? So let's look at that. So my list is still the same. Let me write it down for us just so we can remember. Okay, so this is my list. So there is 3 ways in which we can use list slicing, right? So this is indicated again by square brackets because we're indexing a part of the list, but we also use a colon inside, right? So the first number before the colon, so this is how we write it, right? So we have one number over here, then we have a colon, and then we have another number, right? So this first number over here is where we're starting from. Okay, so this is the start index. Okay, and the second one is how long we want it to be. Okay, so let's look at how this works. So the first example we have is my list, and then we have 3, and then we just have a colon and nothing after that. So what that means is the starting index for the portion of the list is, oh, sorry, the starting portion of the index is this number, right? Is this number. Okay, So what do we have over here? We have 3. So 3 is the starting index. So let's see, what is this 3 index? 0, 1, 2, 3, right? So we have this number over here. So this is our starting index. The second number is not specified over here, if you see, right? It is not specified. So we just ignore it and we just keep going till the end, right? And that is what we have as the output over here. We are going to look at examples of this as well, but let's just get in the theory for now, okay? So now we also have a negative index to start with, right? So what did we learn about negative indexes? We start from the back. So it is -3. We start with -1 from the back. So we have -1, -2, -3. So what will be the starting numbers? The starting number will be 8, right? And then as the second number is again not specified, we go till the end. So we have 8, 9, 10 as the output. So then we have from one index to the other. Okay. So the first index is inclusive. What this means is we include the number in it. So as you can see, the first time we grabbed it, the third index, we included 4 in our answer, right? And the second time also, when we had -3 as our index, we included 8 in our answer, right? So similarly, here what we'll have is 3 till 5. So 0, 1, 2, 3. Let's go till 5. 4, 5, right? So what do we have at 5? We have 6. Now we just learned that second is exclusive, right? So what that means is the 6 will not be included. So it will go till 5, right? Because this is how long it goes till. So the output is 4, 5. Similarly, we can also use negative index to determine how much we want to go till. So what is -1? -1 is 10, right? So we exclude 10 and everything before it comes in the answer. So we have 4 till 9, right? So up to some index, we can also exclude the first number altogether and start from the beginning. So right now, all of this probably sounds a little jumbled, but let's look at a few examples. Okay, so let's make this list the same as the example in the slides. Okay. So first, we want to start with just the index, the starting index, right? So let's say we want to create a list that starts at 4 and goes till the end. So for that, we will have 0. So we start with 0, 1, 2, 3, 4, and so on, right? So the starting index for 4 is 3. And then we put a colon to denote that we want a slicing. And because we want to go till the end, we don't need to specify the second number, right? And then we can print this out. So as we can see, we have the list from the third index until the end because we didn't specify the second number, and the starting number is the third index. Okay. So we can also slice with a negative index, right? So let's say I want to make a slice again from 4 till 10, but this time I want to use a negative index. So can anybody guess what the answer will be? What will come inside the square bracket? Just tell me that much.
You can use -1, like -3.
-1, you said? Sorry, you weren't clear.
I said you can use -3.
-3?
Yeah.
Okay. So
that will start.
I want a list from 4 till the end, and I want to use negative index. So that will the answer be -3?
No, -7.
-7, okay. So let's look at the answers in chat. We have -3, -3, -7. Okay, let's look at what the answer is. Let's try both of them. Let's see what happens. -3, okay. We have -7. Let's take this one out. Okay. So the first one gives us 8 to 10, and the second one gives us 4 to 10. So let's look at why this negative indexing is giving us these answers, okay? So how do we start negative indexing? We start from the back with -1. So we use -1, -2, -3, -4, -5, -6, and we have -7, right? So at -3, we actually have 8, and at -7, we have 4. So if we want a list from 4 till the end, we have to use the negative index -7. Is that clear? How we're indexing it from -7 till the end. Okay, so now let's try to create some indexes that don't go till the end. So let's clear some of this out. Okay. So now let's say I want a list from 2 till 5. Can anybody tell me what I should put inside the square bracket? Put it in chat. Just type the answer as fast as you can. Whatever you think the answer is. It doesn't matter if it's right or wrong. We're all trying to learn, right? So we have 1 to 5, 1 to -5. Okay, we have like a variety of answers. So let's try to break it down, right? So first, so we want a list which is 2 till 5, right? We want all 4 of these numbers, okay? So what we'll do is, first we'll see the starting index. So the starting index includes the number. So we want to use the index that is of 2, right? So what is that index? 1. So let's write it down. I'll get rid of this part. So print. All right, so we have 1, right? So now let's look at what the second index will be, right? So we have 2 ways of going about this, right? We can either use the negative index or we can use the positive index, and neither of those answers are wrong. But the important thing is you have to specify the index for 6, because the second index is not included, right? It will take the number before it and not the number that is at that index, right? So here we have the negative index already written. So I'm going to use this, which is -5, right? So let's put -5 over here. And we'll see what the answer will be. So we have 2, 3, 4, 5. Okay. Is it clear how we used the negative index of 6? Because it was excluded, and that's why we use the one after 5 and not of 5. Because if we have, let's say if we put -6 over here, then we exclude 5 and we only get 2, 3, and 4.
I have a question. It looks like you use both positive index and negative index together.
Yes, so that is possible. We can do that. So the left side is one index and the right side is a separate index. So as long as both of them are correct, it doesn't matter which one you use.
But you can just use positive alone or negative alone for the
Yes.
left and right, right?
Yes, correct. So if I want to use the positive index, let's say, instead of the negative index in the second place over here. So let's see what the positive index for 6 is. So we have 2, 3, 4, 5, right? So if instead of -5, we just put 5, that is also correct. That will give us the correct answer. So in this case, you will see that the negative index and the positive index is somehow the same. That is not usually the case. But in this case, both 5 and -5 will give you the correct answer. Is it clear? Okay, so let's go back to the presentation. Oh yes, we forgot to do one type where we're going from the start till the finish. So let's go back to PyCharm for a moment. Okay, so what if we want to start with 1, right? Well, what we can do is we can either write 0 over here, right? So let's say I want to list from 1 till 5. So if I do this, it will give us the right answer, right? This isn't wrong. But if instead of this, I just omit it, I just don't put it over there, that will also give us the same answer. So technically, writing 0 over here and not writing anything over here do the exact same thing. They basically mean we're starting from the very beginning of this list. Okay. And as always, you can use negative index in the second place as well. So if we put -5, it gives us the same answer. Because in this case, 6 has both the positive and negative indexes as 5. Okay. Let's go back to the presentation. There we go. So next we have list methods. So most array methods also apply to lists. So you can, I will be uploading the lecture for last week soon, and this lecture will also be uploaded with that. So in that, you'll be able to see that we did some array methods. So those can also be used for lists. Most of them will apply over here. So let's look at some additional methods. So the first one we have is count. It counts the number of elements with the past value. So for example, first we have a list which has 3 ones in it and 4 twos in it, right? And then we did dot count, and then in the bracket we have put 2. So what this will do is it will count the number of times 2 appears in this list, and it will give us the answer. Okay. And then we go to extend. So my list dot extend, and then we put another list in there. So what this will do is it will add this list at the end of the existing list that was first specified on the left side. Okay, we're going to look at examples, so don't worry if this is going too fast. My list dot reverse. So what this will do is it will take the list that you have, put it in reverse, put it back into that variable. So the list will become permanently reversed like this. So you can always reverse it back, but the variable, the list itself will be changed, right? So sort reverse equals false. This sorts the list into ascending order. You can also do set reverse as true to sort it in descending order. Okay. So we'll look at examples of all 4 of these now. Okay, so somebody wants me to try a very interesting list slice. So let's try that as well. Let's go back to PyCharm. Okay, so what he wants me to try is 5, 0, right? Let's see what happens. So we get an empty list because if we start with 5, which is the 6th, and then we want to end at this place, we just can't do that. So it gives us an empty list. So there's the answer for that. Sorry if you were hoping for something a little more exciting. So let's close this out. Now we'll try the count method. So for that, we need a list that has some repeated numbers. So let's make one. Okay. So what we can do is we can print list one dot count and then 2. So what this will do is it will count the number of 2's in there. So the answer should be 3, right? So if we run this, we have 3. Similarly, if we count the number of times we have 45 in there, we can also do that. Right? So if we run this, we have 2. Okay. Can you please mute your mic? Thank you. Okay. So is everyone clear on what count does? It's pretty straightforward. You can also always store this in a variable, right? So for example, let's say you want to do this, and then you print X. So this will become a number, and then you can always print it out. It's still the same answer, right? So now what we want to do is we want to do extend. So let's make another list. Let's call it list 2. In here, we'll put in, let's say 4, 5, 6, right? So let's print both of these out first, just so we can make sure we're not doing anything to them beforehand, right? Now, if we do list 1 dot extend list 2, right? Now, if we print list 1, let's look at what the difference will be. And let's print list 2 as well, just for fun. All right, so this was list 1 before we did the extend, right? It looks exactly the same as this. Then over here we have 4, 5, 6, which is list 2, exactly the same as over here. Now over here, 4, 5, 6 has been added to the end of list 1, right? That is why when we print list 1 after extending it, it is giving us this list instead of the shorter one, right? Because we extended it over here. And then list 2 does not get changed because it is being used to extend list 1, but it still just remains the same. So is it clear? Extend, count. So let's go to reverse. If you have any doubts, please put it in chat. I'm going a little fast through these, but they seem pretty straightforward. So let's look at reverse now. So let's print list 1. Okay. Then let's reverse list 1. Oh. And then print it again. Let's look at what the difference will be. So as we can see, the list has simply been reversed, right? And we can just do this again if we want to. As many times as you'd like, right? You can just keep reversing it. It doesn't matter. Then we have sort, right? So this list is already sorted. So let's make something that is not this sorted. Okay, so that looks pretty jumbled. Let's try to use sort. All right. So let's print the list out first. Then we sort it. So if we do this, this is the same as saying this. So this reverse value has the default of false. Doesn't seem to be working. Let's try it. Okay. Doesn't say anything, so let's keep going. Print list one. So as you can see, we put reverse equals false, which means ascending order. So it got put into ascending order, right? So if we simply omit this, don't put this in here, it will give us the same answer. So the default value for reverse is false. But if we put true, we get descending order. Okay. So are there any doubts in all four of these? Should be really straightforward, I hope.
What was the difference between lists sort reverse true and lists sort reverse false?
Yes, so reverse true gives us descending order, right? It started with the 9 and it goes to 1, right? If we put it as false, it will put it in ascending order. So it starts with the 1 and goes to 9, right? Make sense?
Clear. Thank you.
And then if we
Sorry,
simply
sir.
remove reverse equals false, it is the same as saying reverse equals false. So it doesn't matter if you put reverse equals false or not, but if you put reverse equals true, then it is descending order. Okay, so Matthew, you have your hand raised. Go ahead.
Sorry, sir. Why not ascending and descending? Why using false and true?
That is simply how the makers of Python decided to have it, and we're using it like this. And I would assume it is so that we can use as many primitive data types as possible, because ascending and descending aren't exactly data types that are described, right? And true and false are already described. And we'll look into how functions are made later, like how we can make functions like sort. Obviously, we're not going to make something as complex as a list sort, but we will be making some custom functions of our own later on in this class.
All right, thank you, sir.
Okay.
Just for God's sake, can you try to put ascending in the biggest of so just this what happened?
Sorry, I can't hear you properly. Could you repeat that?
Can you hear me now?
Yeah, I can hear you.
Yeah. So I was saying, just for us to appreciate what I'm saying, in the brackets after sort, can you try to write ascending to see what if you and then you print it, what comes down there?
So I write ascending over here.
Yeah.
It should just throw an error, honestly. That's, yeah. Ascending is not defined.
All right.
Yep. So basically reverse means, so when you're sorting something, usually what you'll do is you'll start with the smallest thing and then you'll put the biggest thing at the end. So what they mean by reverse is that you do the reverse of that, and if it's true, you're doing the reverse of it is true. So you're actually doing the reverse of how it's sorted usually. So that is how it's interpreted. That's how I interpret it. Okay, so let's go back to our presentation. So let's see what we have next. Lists and strings have a useful relationship. So sometimes what you can do is you can think of a string as a list of characters. So what is a character? It can be an alphabet, a space, an exclamation mark, anything like that, right? So as as a string is a list of characters, you can use some concepts and methods of lists on strings. Okay. Oh, so what that means is you can use slicing in strings. So if you take a string and then you try to use square brackets and then the colon and then try to slice the string, you can do that, right? You can also index the string, and some methods work in it, right? So I'll leave it to you to find out which methods work and which methods don't. But count, as you can see over here, count works, index works, but sort does not work. Okay. So for methods that don't work on a string, simply cast to a list first, then join back together. So this method over here describes how you can convert a string to a list first, and then what you can do is you can use the method that is not available on the string. You can use it on the list and then convert it back to a string. So that is something that can be very useful when you're trying to get out of a situation. So I will leave it to you to find out more about this relationship. Okay, let's move on to tuples. So this is the last type of data structure we're going to be looking at, the last type of collection we're going to be looking at. So what is it going to be? It is an ordered collection of non-unique values that are of any type and are immutable. So the key difference here from a list, who noticed it and who can tell me? Anybody? No?
Yeah. The key difference is that in lists is mutable, whereas tuple is immutable.
Correct. So as you can see over here, tuples are immutable, right? So let's first look at how it's similar to lists. So it is ordered, right? So the order in which you put stuff in, is it the order in which it will stay? You can put in non-unique values. So if we put in 2 or 3 of the same exact numbers or same exact data type, it will simply treat them as different and it will continue putting them in, right? So in the output, you can see we have 2 2s, 3 3s, 4 4s, 2 hellos, and so on, right? So any type, unlike an array, when creating a tuple, you do not need to specify the type of the element within the tuple, right? So in an array, we are bound to one type of element. In a tuple, we're not, okay? So it is immutable. So the difference here is you can't use the index to change anything in a tuple, right? So if you did this to a list, it would have changed the ninth element to 10. But in a tuple, if you try to do this, it won't change it. So now some of you might be thinking, well, why is that useful? It could be useful if you're trying to keep something maybe protected, right? Maybe you want it to be protected. Maybe once it has been created, you don't want anything to manipulate that data. So there could be some use cases where tuples are useful, right? So like lists, tuples can be indexed and sliced, right? You can still index them. You just can't use the index to change the uh, element or at that index, right? So let's go back and see what the difference was. Here, we were using the index to change the element at ninth place to 10. And because it is immutable, it did not allow that. But over here, we are simply using the index to see what element is over there. And that is totally fine. You can do that. You can also slice the tuple and it will give you a new tuple that is a slice of the original tuple, right? So they are still immutable. So again, this is being iterated over here again. Do not try to change anything inside a tuple. It is not possible, right? Tuple methods. So first you have the index method. right? It returns the index of the first element of the tuple that matches the value passed. So my tuple, this is the tuple. So let's index it, right? 0, 1, 2, 3, 4, 5, 6, right? So at the 6th place, we have 4, right? So the first element of the tuple to match that value is this one, which is at index 6, which is what we get as the answer, right? Next, we have count, returns the number of instances of the value passed within the tuple. So if you have a tuple and you count the number of 5s in there, so are there any 5s in there? No, so it will give you a 0. Count the number of hellos in there, there's 2, so it will give you 2, so you can use these. So you can't use many of the list methods that modify lists, right? Because you can't add elements, you can't remove elements, and you can't update the value of elements in a tuple, okay? So let's look at some examples of tuples. Okay. Let's say I made this tuple, right? Now, if I try to change anything, right? Let's say I want to make this element 4. If I try to do that, it will tell me that that is not allowed. Okay. But if I want to access that element, just use what's in there, that is totally fine. I can print out this value. So as you can see, 3 is printed out, right? Can you please mute yourself unless you have a question? Thank you. So yeah, that's basically the only difference between a list and a tuple. Other than that, whatever you can do with a list, you can also do with a tuple, as long as it doesn't involve changing anything about the tuple. Make sense? All right, so I think we're done with today's time. So I'm going to stop recording.